Historically, as software projects grew in size, it took longer and longer to build them, and engineers explored ways of speeding things up. Let's look at a simple build, which is a sequence of steps called tasks, such as compile, test, or package. Tasks have inputs, such as files or configuration options. They execute an action, and they produce outputs. The outputs of a task can be the inputs to another task. Engineers noticed that a considerable amount of time was spent executing the action of tasks. They also observed that most tasks were deterministic. That is, the same inputs would always produce the same outputs. So, when a deterministic task is run, if the outputs from the previous execution are still there and the inputs haven't changed, the outputs could be reused without having to execute the action, thereby saving time. Build systems were modified to track the inputs being used to create outputs for deterministic tasks and check if the outputs could be reused before executing the action. This feature is known as incremental build support. The idea behind this feature is that if deterministic task action work has been recently done, don't repeat it. The limitation of incremental build support is that it only looks at the current available output. Let's say you run the compile task that produces compiled output. You then change some source code and rerun the compile task, which now produces different output. You change your mind and revert your source code changes. The compile task will have to rerun its action even though a few moments ago you had the matching compiled output. What if you could store historical task output instead of being limited to just the output from the immediate previous execution? When a task is run, if the currently available outputs were created with different inputs, the build tool can check a local cache to see if there are outputs available that were created with the current inputs. If so, it can copy the outputs to the build directory and skip executing the action, thereby saving time. If the local cache does not have the outputs for the current task inputs, then the task action executes. A cache key is created using the hash of the task inputs, and the compressed outputs are stored in a local cache using the input hash key. Next time, if the task is run with the same inputs and the currently available outputs were created with different inputs, the build tool creates a cache key using the inputs, sees there is a cache hit for that key, and uses the outputs in the local cache. Using a local cache with historical task output is a major performance improvement over incremental build support in some use cases. The idea behind this feature is that if deterministic task action work has been done locally before, don't repeat it. The limitation now is that the build tool has access to task outputs from only local build history. If you're working on a large project that is frequently committed to, you will often pull changes to not be out of date and avoid large merge conflicts. When you do this, many task inputs will be new and not encountered locally before. Therefore, the build tool will get cache misses in the local cache. Also, continuous integration builds that run on ephemeral agents or clean environments do not have a local build history to leverage, so they cannot benefit from a local cache. What if, in addition to a local cache, there was a remote cache? Whenever a person merged a pull request, a continuous integration build would run that would execute actions and produce outputs. These outputs could be stored in a remote cache with the key being the hash of the inputs, just as with the local build cache. Now, when you did a code sync and ran a build, when the outputs were not found with incremental build support, or in the local build cache, the remote build cache could be queried and the matching outputs downloaded and used, thereby saving time. The idea behind this feature is that if relevant deterministic task action work has been done globally before, don't repeat it. This feature was pioneered at large tech companies. Here is a blog post from Google dating back to 2011 where they discuss the usage of a remote cache and constructing the cache key using task inputs for their internal build tool. Their engineers experienced more than 90% cache hit rate, which is significant. Here is another publication from Microsoft about their internal build cache service, which they called Cloud Build. The time savings from using a build cache can be significant. After enabling local and remote caching, the Spring Boot project saw CI builds speed up by 3 to 4 times, and developer builds by up to 20 to 30 times faster. Those are some serious time savings. Going back to that comic, now instead of waiting several minutes for a build to complete and having to context switch back once it's done, you can kick off a build, check your messages, and then resume working. A big productivity difference. This video is just a sample of what's available in the free DPE University Learning Center. Head over to DPE University to take the full course, earn a LinkedIn certificate, and unlock your potential with Gradle Build tool. You can find links in the description below.